right? So to begin with, if I place panels on this particular route, I'll just click on fill face, and you will see that my panels are automatically placed on this route. Here with the help of compass, if you see, right, and if I just click on any one of my panel, so herein you will see that my azimuth value right now is at 180 degree, right? So as you can see that these panels are at a particular angle of 180 degree, right? Now, what do you mean by 180 degree? Basically, that is your true south orientation. But I'm repeating this again and again. What is true south? What is 180 degree? So I'll explain this to you with the help of this slide. So if you see, right, our purpose here is, as we all know that the equator receives the most amount of direct sunlight. There you'll be having the maximum irradiation because it will be direct, right? So the what we try to do in the solar industry is to place the panel directly towards your equator, right? And in order to do that, we place the panels in true south direction. But why we place the panels in true south direction? That again depends upon the hemisphere in which you are. Suppose a person is sitting in the northern hemisphere, right? So for that particular person, the equator will be in the southern direction, right? Hence, they will be placing the panels in the true south direction. Whereas the person who's sitting in the southern hemisphere, for him, the equator will be in the northern side. And that's why the panels will be placed in the true north direction, right? So that's the basic concept behind your azimuth angle, right? So as you can see that right now my panels are placed in the true south orientation, right? How does that again affect your generation, right? So again, your generation is affected by this a lot. For example, suppose for this 180 degree, that is true south, right? And my total size is, suppose I delete these panels from here, and my total size right now is 22.66 kilowatt. Suppose I add one more inverter over here, and let's say I add a 19 kilowatt of inverter over here, and let's say I place it over here. Right. So as you can see that now my total DC size is 22.68, my AC size is 21.5, and my load ratio is again 1.0. So what this 1.05 means is that I'm doing an overloading of 5% in this particular system, right? So now if I just save my design and do the generation part for you, you will be able to see that my again specific generation performance ratio will come right? But suppose I don't want my panels to be placed in the true south orientation, right? I want my panels to be placed parallel to this, right? So first, why would I do that, right? So that there are multiple reasons of doing that. Suppose in case you are an installer and you want to make a balance between your generation numbers and your capacity, right? So in those cases, being an installer, it becomes a tussle for you that in which orientation should I place my panels in order to get maximum capacity and maximum generation out of it. Because if you are placing your panels in the true south orientation, and if there are no nearby buildings or high-rise structure around it, you will get maximum generation. Whereas if you are placing these same panels in some other orientation and the other parameters are same, you will get less generation, right? But there are sometimes, for example, in this group, suppose I change my azimuth from true south to say parallel to this loop, right? So you will see that now my size has decreased, right? And based on that, my AC size was also the same, and my load ratio is changed, right? So as you can see that now my panels are placed in this orientation, right? And if I do my generation for this particular part now, I'll just save this design and I do my generation. You will see there will be a huge difference in my generation numbers, right? But why is that? Right? So that is because now the panels are not facing directly towards the sun, directly towards the equator. Hence, it will be receiving less direct sunlight, and hence it will impact your generation a lot. So while we are designing a PV plant, we need to take care of these two parameters, that what should be the optimum tilt at which we should place our panels. And if we are making out a balance between your capacity and your generation, we should choose the proper asset. Moving to the next factor, we have the shading losses. So again, this is a very, very important factor. So I'll explain that to you again with the help of this example. So if I go to my 3D mode now, and I change my panels orientation back to the true south, and I'll just update it, right? And if I show you, this is how it looks in 3D, okay? And as you can see that there are various nearby obstacles on this particular route. We have one over here, we have one over here, right? And suppose I just save this design and I'll show you one feature which we call as sun simulation. And if I just turn this on, you will be able to see the shadow pattern in 2D as well as in 3D for every single day of the year and every single sun hour. So for example, it's 25th today, and the time is, so let's say it's for 5:30 or 6:30. Right? For 6:30, because there's no sun, hence your panels will be shaded. But suppose I move at 10:35. So this will be your sun path that is tracked by your software, and based on that, your shadow pattern is shown. Suppose I change my date from 27 to say 21st of December, which people do generally in the solar industry. So you will be able to see the shadow pattern of various objects that is coming onto your panels. As you can see, right? So at this particular time, right? So if we take into the consideration that the time being from 10 to 4, right? And I start from 10, so you will be able to see that 10, 11, 11:30, then at 2. So at 1:32, this panel will start to experience some shading, right? And as we told you in the last masterclass, that panels are arranged in series as well as a panel depending on your needs. So if these panels are arranged in a series, right, then it will impact your whole output, right? That's why we need to make sure that none of our panels are being shaded and the internal shading and the shading from the nearby objects are taken into account. That's where the solar labs comes in. So this is a very, you can say it's a very unique way of doing the shadow analysis. And people do this for once for a single day in a year, right? But what happens really is that in residential cases specifically, there are a lot of time, let's say 8-9 months of time during a complete year, wherein the panels will not be having shadows because that particular area will not be having any shadows for 8-9 months. But since we are doing it only for 21st of December, which is the longest, which on which day we have the longest shadow, we will be having shadows over there, right? And we are unable to do anything because we do not have a tool like that. Neither we do have that much time that we do it for every single day. Hence, we are unable to place panels over there, and we have to compromise on our capacity. That's where we should, use multiple tools wherein we can do this analysis for every single day, right? So similarly, just hold on a sec. I'll take one question. Right. So like I was saying that you should take care of your shadows if you want your proper generation, right? So this is one way of doing it wherein you can map out your shadows and do it for every single day, right? But you see that can be very hectic thing to do for every single day, right? That's why people are doing it for 21st or a single day, right? But if we want to do it for the complete year, then how to do that? So for that, we have another tool which we call the solar axis. So as you can see in this particular image, you will be seeing that these panels are having multiple colors over there, right? There are green, orange, red panels, right? So now what these color means, right? So I'll again explain this to you with an example. So if I just save this design for once and I show you the 3D mode, so you see that these particular obstacles, they are at a certain height and panels are placed like this in the true south orientation. Suppose there's one feature of ours which we call as solar axis. And if I refresh this, so you will see that there will be colors all over your panels, right? As you can see that there is dark green, then we have some red color, some orange color, right? So if I click on any single of the panels, suppose I click on this one on the top right of the corner, you'll see there's a value called average solar axis, which says 98.6. Similarly, for this orange yellow panel, it is coming out to be 91.3, and for this red panel, it's 81.9. So now what does this value mean actually? So if I show you for this dark green panel, it is coming as 99.2. So basically this value means that on 99.2% of time throughout the year, this panel will not be having any shading loss. Or you can also put it in this way that only for 0.8% of time throughout the year, this panel will have some shading loss. Whereas this particular panel will be having it for around 9% of the time in the year when it will be having some shading losses. Right now, suppose let's say I increase the height of certain obstacles over here. As you can see, suppose I change the height of this particular obstacle from 2 to say 5 meters, of this particular from 3 to say 6 meters. For your reference, I'll show you this is how I have increased the height. And now let's see what will be the change on my panel. So again, if I just save my design, right? First of all, I'll show you with the help of sun simulation feature, right? So you see earlier your shadow pattern was a lot different, right? For this particular day only and this particular time, now it's a lot different because now the height of my obstacle has also increased, right? But how the solar axis will calculate it? Again, I'll just go to my solar axis. I'll click on refresh, and this time you will see there will be tremendous change in the color of my panels, right? As you can see that now my panels are reddish over here, more orangish over here, and the color is also, a lighter tone of green over here, right? So if I click on this panel now, it says 78.5. Earlier it was 91. Right? So that's fast. That's how fast the artificial intelligence technology works. That's how the shadow analysis and solar axis is done, right? So this is very important thing. Before you design any system, before you do any installation, you need to make sure that you are getting proper generation which you are quoting, right? Then one more feature that I'll just tell you is about the heat map, right? So if I just save this design and I remove this, hide this. So if I turn the heat map on, so this time you will see that there will be colors on my roof. Basically, I'll just be explaining you what these color means, what's the purpose of these colors. Again, this is another parameter by which we should place our panels. Right? So as you can see that there are various colors on this roof, primarily being red, then we have some yellowish color over here, and then we have some dark purplish color also over here. So basically, this is your measurement or of your direct radiance that is coming onto this. Right? So whenever we are going to install, as an installer, the first thing that we try to seek is where we should place our panels so that we get the maximum generation, right? So in order to do that, in order to automate that, we have this tool wherein you can place the panels by using this. Right? Now let's move to some of the other factors which influence your PV generation, primarily being your losses, right? So there are various types of losses that are taken care, that should be taken care in the while you are designing a plant. Primarily, there are three. That is your irradiance loss, your DC losses, and your AC losses. Right. Among these, there are various subcategories wherein you can, change your losses, or you can just keep track of your losses and design your plant according to that. Right. So, for example, there are multiple losses that should be taken care in the irradiance loss. With one being which is very important, is your soiling loss. Right. So now, what is your soiling loss? So soiling loss basically is the loss that that your panel, the generation that you lost because of the, you can say, suppose you have a panel, right, and you are not cleaning it. So after long, after some time, you will be seeing that there will be dust that will be accumulated on your panels, right? There will be, let's say, example of a particular city which is very polluted, right? Let's say the Delhi, right? So there's a lot of pollution in Delhi. Hence, there will not be direct radiance that is coming onto the panels, right? But what happens because of this? Because there's so much pollutions, or because there is so much dust. Suppose we are installing a plant which is near a very, which is near a site which is under construction, or you are installing a plant, let's say in a steel factory where there are a lot of fumes. So in those particular cases, what happens that the dust which is rising will get deposited on your panels, and it will ultimately affect your generation because it will enter your direct radius that is coming onto your roof. Similarly, we have other losses, for example, your horizontal global direct radiation, right? So if your plant is not placed a proper tilt or a proper angle, it will receive less direct radiation. Ultimately, that will affect your generation. Similarly, we have other losses like DC losses, right? We have temperature losses. We have your AC losses. So let's talk about your temperature losses. So for example, every single panel, right? It is created by keeping certain conditions in mind, which are called your SCCs, that is standard testing conditions. That at a 25 degree centigrade, this panel will be giving you this much generation, right? So if the temperature of that panel will rise above the 25-degree, it will again affect your generation. If it is getting much lower, it will again impact your generation. So we need to keep all these factors in mind while we are, designing a solar power plant. Similarly, there are a lot of DC losses. For example, your DC ohmic losses, your ohmic wiring losses, whenever you are doing your cabling, right? So as we all know by Ohm's law that whenever there's a voltage and current, there will definitely be some heating losses, right? So those losses we need to take care. If we are designing a very big plant, we should make sure that we are using good quality cables with the, you can say high diameter, more diameter, so that our losses can be reduced. Similarly, there are loss of AC losses also. For example, you have your DC to AC conversion loss. So this is a very, very important loss whenever you are using an inverter, right? So we all know that the general process over here is that your solar panels will receive sunlight, it will convert it into electricity, it will be DC power, then an inverter will convert that DC power into AC power, and then it will be supplied to your home, right? But during all this, there's a lot of conversion that takes place, and as we all know, during these conversions, there is some losses. So that's where this loss comes from, and we need to make sure that we minimize our losses in order to get the best result, right? So this where our DC to AC conversion loss comes. So we need to make sure that we are using proper materials. We are doing everything by utmost precision so that we can reduce this loss. Then you also see there is one more loss called your clipping losses. So basically, that's a very interesting loss. So suppose, let's say I have created a system of say 110 kilowatts, and I have used an inverter of only 100 kilowatts. Right? So I'm doing a overloading of say 10%. Right? So when will my clipping loss come? So the clipping loss purpose is suppose your panels are giving you the maximum output. Right? Suppose you are supposed to your system is supposed to produce 100 units, right? And it is producing 100 units, but you have used an inverter which can only transfer, say, 95 of the units, right? So then those 5 units will be counted in your clipping, right? So this is again very important thing that you should make sure while designing a plant. Then again, one of the losses is your unavailability loss. So this happens in case of your on-grid system, wherein if your system is not connected to, if let's say your system is connected to grid and there is no electricity, again, your solar panels will stop generating electricity because again, it is a security issue, it is a safety issue. Hence, those type of losses are also taken care, right? So these are certain parameters, certain losses, certain, uh, 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 factors that affect your PV generation while you are designing. So in order to do that in our software, what we have built is there are certain losses such as irradiance loss. So those losses are taken care by the software itself because we have various tools to do that. We have irradiance data, we have weather data sets to take care of that. But there are certain losses which one should put manually because they depends on designer to designer and installer to installer. So for those losses, you can just go to your design settings, go to your losses and change those losses according to the manual. Now, if anybody is having any doubts, any queries, you can please put them in your put them in the Q&A section. You can also raise your hand if you have any doubts.
Yeah, Rachit, there is one question from Lalit Rawat on what factors pitch between arrays depending.
What can hear you? Is it in the Q&A section?
No, it's in the no, it's in the chat. He's asking about the row spacing, I think, like on what factors the row
Pitch
spacing is
between
dependent.
arrays dependent.
Yeah.
Right. So, Mr. Lalit, your row spacing is basically dependent on the tilt that you are providing, and sometimes people also change their row spacing, put it manually according to them. For example, I'll show it to you with the help of again an example. Right. Let's say I'm creating a subarray over here of panels. I'm putting an array of panels over here. Right. So now if I show you, go to the subarray, here you can see that my tilt is right now 20 degree, and my row spacing is automatically calculated by the software based on this tilt as zero point 0.7 meters, right? So you can see that if you see this much will be your row spacing between your panels, between your this two rows of panels, right? But suppose if I'm changing my tilt, right, then what will happen is, so I'll just explain that to you by giving you the example of the shadow pattern. So if I go to my 3D view now, right? So you can see that if I change my shadow pattern, you will see this will be my shadow pattern, right? So you can see that let's say at 9:33, right? My shadow pattern will start to change, right? And by, so you can see that at from 9:30 to say 4:30 or even 4, right? At 4, my panels will have some shading losses due to these panels, right? So this is called your internal row shading. So if your front row of panels is uh, having, is creating a shadow on your this layer, this row of panels, it will be called as internal row space, right? So in order to minimize this, we need to give optimum gap between your two rows, which is called as internal row space. So that depends upon your tilt. More be the tilt, right? If I change the tilt, suppose I change this from 20 to say 25. Now if I show you in 3D, so you can see that now my panels are more inclined, right? So again, this time you will see that my panels will start having shadow at 27 only, right? So that's how, in order to make sure that your panels does not receive any internal shading loss due to internal row spacing, we should increase our internal row spacing. Hence, if I go further down, you will see that the software will automatically calculate your row spacing, right? It will automatically increase it because we don't want any of the shadows from this row to go onto the this row and affect my generation. So on these parameters, we select our rows. Okay, so there's one more question from Mr. Chandra Kumar. How we select the inverter size of a system? If it's greater than system capacity or below the system capacity? Right. So Mr. Chandra Kumar, that's a really great question. So if you see over here, so for this particular case, what I've done is I'll just delete this for once. Right. So that again depends on various factors. What should be the inverter size, right? So basically, there is two type of inverter placements that we do. So that's what we calculate by load ratio. So if you see, if I'm installing, suppose a plant of 100 kilowatt, right? And I'm placing an inverter of 100 kilowatt. My load ratio will be 1. That is my DC size to my AC size. Hence, the same capacity is installed via my same capacity is installed by my panels, and I'm installing the similar capacity of inverter, right? But suppose I'm installing a system of 110 kilowatt and I'm installing an inverter of 100 kilowatts only, right? Then I'm doing overloading. That is, I'm doing a 10% overloading because now my inverter size is less as compared to my DC size, right? So now how it will impact, right? So basically what happens is that 110 kilowatts, suppose if I'm saying that I have created a system of 110 kilowatt, that does not mean that for complete 365 days, it will perform at 110 kilowatt, right? There will be hardly 15 to 20 days or even 20 to 25 days in a year when it will be performing at its best. Otherwise, it will always perform at a lower capacity than that is stated, because those particular panels, those particular capacity is stated by taking in care of the STC conditions and various losses. But when you are installing a plant, practically, ideally, it won't happen. So in those cases, if you are installing a inverter of 100 kilowatt only, your generation numbers won't affect that much, because around 90% of time your DC capacity won't shoot past 100. It will be around 100 only. Hence, you will be in a better situation to do the overloading. So generally in solar industry, people do overloading of 15 to 20% also, right? Then what is underloading? Underloading basically is that you are installing, suppose a DC size or a capacity of 90 kilowatt, and you are installing an inverter of 100 kilowatt, right? So again, there will be your see, the simple logic is, if you are taking an inverter of 90 kilowatt, it will cost you less. If you are taking an inverter of 100 kilowatt, it will cost you more, right? Similarly, if you are taking an inverter of 110 kilowatt, it will cost you more than your inverter of 100 of only 100 kilowatt. So based on the costing, you should decide what you should do. Second factor is your efficiency, right? If your plant is not going to reach 110 kilowatt for most of the time, why to put so much cost in the inverter, right? So these are some parameters on which you select your inverter size. Okay, there is one more question from Mayur. How to find a proper tilt? So, Mr. Mayur, in order to find the proper tilt, you should be aware about the latitude on which you are on. Suppose if I'm on a latitude of 20 degree, then ideally I should place my panels at a 20-degree tilt. So that is the way to select the tilt of an panel. But there are again certain factors which needs to be taken care of. For example, suppose I'm a designer and I want to install a industrial power plant, right? So now in cases of in case of industrial projects, what happens is that the owner of that particular plant is very interested in the capacity, right? That no matter what my generation numbers are, if they are somewhat less, I will manage, but I want more capacity. The reason for that is they will get, suppose, environment credits for that, right? So in those cases, you will change your tilt. So based on certain parameters, once you are doing the designing, you have to change the tilt, but ideally you should keep the tilt as that of the latitude on which you are on. Right. So there is one more question from Mr. Priyanshu. Why we give space between module to module? So again, Mr. Priyanshu, the reason is same. In order to minimize our shading losses, our internal row shading, we give space between our two rows.
Yeah, Rachit, the question is module to module spacing. So can I answer this question?
Yeah, sure. You can
Yes.
answer.
Yes, sure, Mr. Priyanshu. The reason why we are giving some space between module to module is, as we all know, panels will be generating more number of temperature. Let's say our ambient temperature is around 25 to 30 degrees Celsius. Our panels temperature will be like 70 to 80 degrees temperature. In that kind of temperature, there will be obvious expansion, the thermal expansion with the frames which you are using for the panel as well as the structure. So there will be a minimal number of expansion in the time of heating, in the time of summer, or in the time of 12 or 1 p.m. in the afternoon. So to just have a capacity or a minimum space for that expansion, we have to give a minimal distance between module to module, so that even that thermal expansion happens, our system will not be destroyed. So that's one of the reasons to have the module spacing. And it will also be helpful for us in the work of O&M. Let's say one particular panel has been damaged. It will be easy for the person to remove that particular panel if he has some space to lift it. So that's another reason.
Great, thanks.
Yeah.
Yeah. So Mr. Chandra Kumar has one more doubt: how to select the size of the structure, right? So, Mr. Chandra Kumar, that completely depends on designer to designer and your client's requirements. For example, suppose there are some clients which want a very high rise structure, or you can say an elevated structures, right? Because they want their space to be utilized, they don't want to waste their space. So in those cases, you have to use a high rise structures. For example, I'll show you. Suppose these particular artists are at a certain height, but if I want to increase their height, I'll just go to server and I'll change the height from 1 to 50 meters, right? And now if I show you in 3D, your height of the panels, the structure will also be increased, right? So again, the cost of the structure will be increased. So again, that depends from designer to designer and what the client wants.
Okay, Rachit, there is one doubt from Mr. Manohar. What is the ideal load ratio?
Ideal road ratio, right? So, Mr.
Yeah.
Manohar, that's again a very, you can say, a question which again varies from person to person and designer to designer. But I would recommend that if you are having a load ratio of one between a range of 1.1 to 1.15 or 1.12, sorry, 1.2, that is an ideal load ratio. That is, you are doing an overloading of 15 to 20% or even 10%. If you are going more than 30%, there are people that even go to 1.3, 1.35, right? That again completely depends upon the type of products that you are using, your requirements, like that, right? But the ideal load ratio should lie between 1 to 1.2 or 1.
Okay, Rachit, there is one more question from Mr. Priyanshu. It is how to use SPD in plant series or parallel.
Okay. May I know what is an SPD, Mr. Priyanshu? Can you please type that? Can you please elaborate on that? Okay. Okay, such vector device. Yes. So, Mr. Priyanshu, for that, basically, we are using ACDBs and DCDBs, right? So, our SPDs are embedded in our ACDBs and DCDBs. So, for example, the basic concept behind that is that whenever we are, having our panels creating the DC power and it is transferred to my inverter, right? So, in order to prevent my inverter, right, we are using a DCDB, right? That is your current conversion box in which we have the SPDs installed. So if my current value or my DC values shoots up uh, the recommended value, it will just trip and it will stop the current right there. Similarly, we have ACDBs wherein will be transferring that AC current from my inverter to my appliances. It will be in between so that it can protect our other devices. Is this software only for operating system or for hybrid or operating system? So, Mr. Umakant, right now the software is only made for your grid connected system, but we are soon going to launch an update wherein you will be able to do off grid as well.
Okay, Rachit, there is
Right. So there's one more question. Basically, Ankita ji, like we are using the Solar Labs software, Design Studio by the Solar Labs. Do we have any more doubts?
Okay, Rachit, there is
So
one question.
yeah. So how you compare this software with pvsys? So Mr. Umakant, again, like pvsys is a very different software when you compare it to our software. So pvsys is one of the oldest software which is there present in the solar industry, and the major purpose of pvsys is to do the generation part, right? And it has set up a benchmark in that particular field, right? Whereas the purpose of our software is not only to take care of your generation part, but also your designing part, your financial part, your modeling part, your shadow part, as well as obviously your generation part plus your sales proposal part, right? So pvsys take care of your generation part because it is a very sometimes it is a tedious task to design a very difficult building in pvsys, right? Whereas you can do that in this software in hardly 20 to 25 minutes, while you are also getting your other aspects like 2D, 3D generations, your financials numbers, right? So that's where the two softwares are different. But if we talk about in terms of generation, where we both are, giving our results. So if you do that, so we will be still in accordance with the previous is, right? We also use the same generation methods which previous is used. Hence, the result will be very much similar to what you will be getting in previous. Yes, Mr. Priyanshu, we do have 350, right? 390 is right now not there. 390 will be launching. We do have 350 and 375. Yeah. So, Ankita, our software is very different than your Google SketchUp. Basically, Google SketchUp is an interior designing tool. It's an architectural use, and it is very good at it. Whereas our software is primarily designed for PV designing. Hence, it is much faster. It will take a lot of less time that it compared to your SketchUp. The efficiency of Google SketchUp, right? If you compare in terms of your shadow analysis, for which majorly people use Google SketchUp in the solar industry, is the efficiency of Google SketchUp is around 92%, right? Because there you'll be doing the shadow analysis for one single day because you have to do it manually over there. Whereas if you compare it with our software, it is more than 97%. So that's where we take a huge leap if you compare it to Google. Yeah, Ankita, like someone, you can just drop your number or your email address in the chat box, and someone from our team will definitely contact. Yes, they will. Together they'll guide you. So we've got 5 more minutes before we wrap up this session. If you have any doubts, anybody, any queries, you can please ask. So Makant, we can definitely discuss that on a separate call. Please feel free to drop your email in the chat box and someone from my team will contact you. I believe since there are no doubts, we will be ending this session. And please stay tuned for our next updates. Again, on next Thursday, we'll be having another session and we'll be coming with a different topic. If you have any suggestions for the next topic, please feel free to put them in the chat box. It will be much appreciated and we will surely take care of the